My name is Malachi Dyer, and this is my PowerPoint on A3 biomechanics. Within this PowerPoint, I will be analysing acceleration and deceleration in detail. Firstly, acceleration is a measure of how fast an object or person is going over time taken. This is a vector quantity, meaning that it has both direction and magnitude within its concept. This can be calculated through finding the change in velocity and then dividing it by the time taken. This can then be used in a visual representation, such as a velocity time graph, which will help find an object's estimated time of travel and distance traveled. This time graph clearly demonstrates the acceleration through the gradient of the line. A sporting example of when acceleration is used could be through an F1 driver at the start of a race. The aim is to get the car to have the maximum velocity as possible in the shortest time frame. If the car started at 0 seconds with a velocity of 0 meters per second and then accelerated in 5 seconds to a velocity of 10 meters per second, the change in velocity would be 10 meters per second as there is a difference of 10. According to the calculation, this would mean that the acceleration of the car would be 2 meters per second squared. Within acceleration, there are two main phases. Now, according to this graph, the first of which includes the initial phase. Within this phase, the object or person is starting from a velocity of 0. It will then have to overcome inertia to build momentum and accelerate. The second phase is known as maximal acceleration. This is after the inertia has been overcome and the velocity is increasing at its highest rate. As you can see on the graph, the gradient is at its steepest here. There are also other factors that affect acceleration. I will use a shot putter to put these into practice. The first is mass. If there were two shot putters and one had the mass of 50 kilograms and the other had the mass of 90 kilograms, the application of force to the ball will be greater on the 90 kilogram shot putter. Application of force is the second variable that will impact acceleration. Lastly, the surface. If the shot putter was on a slippery, smooth surface, they will find it harder to grip and will therefore not be able to drive as much force as possible into the ball. This is because of friction applying a reaction force. Next up is deceleration. This is the opposite of acceleration, which measures how quickly an object or person's velocity decreases over time. This uses the same visual concept as acceleration, using the velocity time graph. Decelerating is used in a lot of sports and is all about overcoming momentum that has been created in a motion. A sporting example of this could be through a pool ball decreasing in speed towards a pocket after being struck by the cue ball. As the graph shows here, the velocity will change by 1.4 meters per second through 6 seconds. Dividing the change in velocity by the time taken, this would result in an acceleration of 0.23 meters squared. Within sport, there is a huge importance for deceleration. So this can be applied to a baseballer who is trying to decelerate to get to the next base. If they are able to do this efficiently, they will increase their average speed from the base to base, which will give them a better chance of staying in. In the same context, if their technique is good, it reduces the risk of injury to the athlete. Lastly, using a different example, if an ice hockey player is able to decelerate quickly, they should be able to get to the puck easier and will be able to change direction much quicker. This efficiency, when decelerating, will decide which team gets the puck first, which is extremely crucial to determine the outcome of a game. Thank you for listening.